This example comes out of section 8.2, transformations of log functions. Okay, in the last example we took the equation of a transformed log function and we ended up having to draw it. In this question we're going to be faced with the opposite. We're going to be given some kind of a drawing and asked to come up with the equation that gets us there. To start off with, we've got the graph of y equals log base 5 of x, and so it goes through this point 1, 0 and this point 5, 1. It has an asymptote at x equals 0. Now the transformed graph is drawn and it looks something roughly like this. Now this is clearly not graph paper, but they will at least label a point, or I'll label a point. If it was on graph paper you could see lots of points that it goes through. But it has the same asymptote, still going, not touching, infinitely approaching x equals 0. And somehow in the question they described to us that only a stretch has been applied. And so it's only a vertical stretch or a horizontal stretch has been applied, and we're asked, what's the new equation? What's the equation of the second graph that's drawn if the first graph was y equals log base 5 of x? Well, if I look at this carefully, I could tell, first of all, that there was no reflection. I can see that just by looking at it at a glance. I can also see that there was no translation left or right, because the asymptote stayed as it was. And if I'm talking about only one stretch being applied, that stretch must have been a horizontal stretch, because my x-intercept has changed. It's going through some new value. Now that one isn't labeled for me, and the graph paper isn't accurate enough for me to say how much it's stretched just because of that point, but definitely a horizontal stretch is the only way that this is going to change its x-intercept. If I only vertically stretched it, that x-intercept should have been invariant. If I look carefully at the point that is labeled 1, 1, kind of gives it away. If the original graph went through 5, 1 and this one goes through 1, 1, it must have been a horizontal stretch by a factor of 1/5. Now, if we think all the way back to chapter 1, when you horizontally stretch something by a factor of 1/5, your equation changes from x to 5x. So the graph that we have drawn, the second graph, is actually y equals log base 5 of 5x. Same as the first graph, but just horizontally stretched by a factor of 1/5.